Welcome to our today's lesson. So today we will continue with the previous lesson that we had introduced on quadrilaterals, and we said that a quadrilateral is a four-sided figure, meaning it has four sides. It's a polygon which has four sides. We also said that in a quadrilateral the angle sum is equals to 360 degrees, and we were able to establish that using the concept of the angle sum of a triangle. We said that a triangle or a rectangle or any other four-sided figure can be drawn as two triangles. Can be drawn as two triangles, and we said one triangle, the angle sum of a triangle is 180, and the other angle sum of the triangle is 180. So when we add the two, that will give us 360 degrees. So we concluded in our previous lesson that the angle sum of a quadrilateral is equals to 360. We also went ahead to look at the different types of quadrilateral. We said we have a convex quadrilateral, and we also have non-convex quadrilateral. Non-convex, we said that one vertex points inward. One vertex points inward, while for the convex, we have all the vertices pointing outward. So non-convex is also called concave. Concave meaning it is one of the vertices is pointing inward. So when one of the vertices is pointing inward, you realize that this vertex here, or this angle here, will be measuring more than 90 degrees. So that means for a non-convex quadrilateral, we have one angle that is measuring more than 90 degrees. But for the convex, we have most of the angles being acute. So those are the two types of quadrilaterals, depending on where the vertices are pointing to. So let's look at some of the properties of quadrilaterals that we know of. We will start looking at the square. We have the square where all sides are equal. And the diagonals of the square are right angled. So we have said that in a quadrilateral, you can be able to draw it as two triangles, and you see that we can be able to draw as two triangles using the diagonals. So let's look at the properties of a square. Square has all the four sides right angle. In other words, they are 90 degrees, all the sides of a square. And we have the diagonals bisecting each other at 90 degrees. For a square, all the two diagonals bisect each other at 90 degrees. In other words, they cut into half. They bisect each other. Diagonals bisect each other. In other words, divides themselves to two equal lengths. So for our square, when the diagonals bisect each other, we have all the sides equal. We have all the sides equal. So the diagonals bisect each other at 90 degrees. We have, again, all the four angles are right angle in a square. In the rectangle, so for a rectangle, we have two opposite sides equal. This side and this side is equal. This side and this side is also equal. Again, we notice that for a rectangle, we have right angled. We have right angled angles. The four interior angles of a rectangle are right angled. We also have the diagonals bisecting each other, and we have all the diagonals being equal. I mean, when they bisect each other, we have the equal length, but they don't bisect at 90 degrees. For a rhombus, which is normally a tilted square, so this is a rhombus, a tilted square. We have two opposite sides which are parallel, and then the diagonals bisect each other, but you realize that these diagonals are not, or the lengths that we get after bisecting diagonals are not all round equal like for the square, but we have this side and this side being equal, and this side and this side being equal. They also bisect each other at 90 degrees. Then about the angles, unlike the square where we have all the angles, the interior angles being right angle, for a rhombus, we have this angle and this angle. The opposite angles of a rhombus are equal. Opposite angles of a rhombus are equal. So this angle and this angle here is equal, while this angle and this angle are equal. We also have, from what we learned in our last lesson on co-interior angles, because this is parallel, this line is parallel to this line here, and we have a transversal, then you realize that this angle and this angle of a rhombus are co-interior. In other words, they add up to 180 degrees because this is a transversal and these are parallel lines. This angle here are found on one side of the transversal and they're inside the other two lines. So they are co-interior. This angle and this angle are co-interior angles, meaning they add up to 180 degrees. That is for the rhombus. Same case with parallelogram. So parallelogram, we have all or opposite sides parallel. Opposite sides of the parallelogram are parallel, and then for their diagonals, they bisect each other, and now we have all the diagonals or the sides that we get after bisection equal. So we have this side equal to this, and equal to this, and equal to this. So the four sides of the diagonals after bisection are equal. Also, opposite sides of a parallelogram are equal. Opposite sides of a parallelogram, or opposite angles of a parallelogram are equal. So we have this side, this angle, and this angle equal. That is, if it's measuring A degrees, this should also be A. And this side, this angle should also be B, and this is B. So we are saying opposite angles of a parallelogram are equal. Opposite angles of a parallelogram and rhombus are equal. This is a kite. We have a kite having two sides being equal. This side and this side is equal, and then this side and this side is equal. Then when we draw the diagonals, you realize that they bisect each other, or they cross at 90 degrees. They cross at 90 degrees, and one of the diagonals is bisected. In other words, divided into two equal lengths, but the other one, no. So this is what happens when we draw the diagonals on a kite. Bisects one of the diagonals, they bisect, or they meet at 90 degrees. They meet at 90 degrees. Then one thing about a kite is that we also have two opposite angles being equal. We have two opposite angles being equal. A trapezium, we have two parallel opposite sides. We have two parallel opposite sides. So for a trapezium, this side is a transversal line. This side is a transversal line, meaning this angle and this angle are co-interior, meaning they are supplementary. They are supplementary. In other words, if this is A degrees, then this one will be 180 minus A degrees. They are supplementary. A plus B should give us 180 degrees. 180 degrees. So these are some of the properties of the quadrilaterals that we have. Let us now look at examples. So this is a parallelogram. Opposite sides are parallel. We are told to use the angle sum of quadrilateral to find the pronumerals, that is the numbers that are, whose angles are not known. So we can be able to apply any concept that we have learned. We know cointerior angles. We know opposite angles of a parallelogram. So all those information can be able to help us when calculating these values here. So we can use the concept of parallel or opposite angles of a parallelogram are equal. If that is the case, then B will be 77. We said opposite angles of parallelogram are equal. So B is equals to 77 because of that. And then if this is 77, what will be our A? So our A is we are saying A plus 77 is equals to 180 degrees. What is the reason? Reason is because when we have a parallelogram, these are parallel lines, and this is a transversal line. These two angles are found on the same side of the transversal and in between, inside the two other lines. So we are calling these angles what? Cointerior angles. We said cointerior angles add up to 180 degrees. So A is 103. A is 103. A is 103. So we can be able now to apply all the concepts that we have learned of a triangle, of cointerior angles and supplementary angles, and also parallelogram and all the quadrilaterals. So what is A? Let us try to find the value of A. We have said the angle sum of a rectangle or of a quadrilateral, like any four-sided polygon, is equal to 360 degrees. So we are given one of the sides is right angled, meaning it is 90 degrees. So our A is 55 degrees. If we are able to add this, we will get 305, and then subtract 360 minus 305, we get 55 degrees. So using the angle sum of a quadrilateral, angle sum of quadrilateral, we are able to get 360, then we can be able to find the value of A. So again, let us find B and A. So again, we have said the opposite sides, this is rhombus, meaning opposite sides are parallel. Opposite sides are parallel, we said for a rhombus and for a parallelogram, opposite angles are equal. So B again. Is equals to 76. So we have 76 degrees here. Then we can be able to find A. How do we find A? A plus 76. That should give us 180 degrees, and these are cointerior angles. Cointerior angles. So A is 104 degrees. So what is the name of this quadrilateral? You realize that this side and this side are equal. This side and this side are equal. This side, this triangle here that is formed down here is bigger than or longer than this. So this one is a kite. So we know for a kite, this angle and this angle here, these opposite angles are equal. Opposite angles of a kite. So the value of A is 100. We are also told to calculate the value of C. C. So we have A 100, we have 100 here, and we have 50. C. So which method are we going to use to calculate the value of C? Angle sum of quadrilateral, we said they add up to 360 degrees. So the value of C is 110 degrees. Yeah. So we also have another parallelogram. We have another parallelogram here, and we have these diagonals. So we are told here is measuring 70 degrees, here is B. So let's find the value of B. Which method will you use to get the value of B? So you realize this, that a parallelogram has two opposite sides parallel. So a diagonal is normally a transversal. So when we have this angle and this angle here, we have a transversal, this transversal line. So we have 70 and 6 and B. You realize that 70 and B are alternate angles. B is equals to 70 degrees, and reason is because they are alternate angles, opposite sides of the transversal. Opposite sides of the transversal. So we have this type of a quadrilateral. This is concave. One of the vertices is pointing inwards, non-convex. So we are told to find the value of A. Because this is a quadrilateral, it has four sides, 1, 2, 3, 4. Then the sum of interior angles are also 360 degrees. So we will say so for us to be able to find A, we must find B. So let us call this side B. So because B is one of the angles in the interior side of the quadrilateral, then all of them will add to 360. So let's add this. So this is so if we add the 3, we get 152. That will give us 360. So for us to be able to get B, let us take 152 to the other side. In other words, subtract B, 152 both sides. So B is 206. When we subtract this, we get 206 degrees. Give us 206 degrees. Now, that is B. The value of B is 206, but we are interested in getting the value of A. So for us to be able to get the value of A, what do we do? So we say A plus 206 degrees. This is 206. We have got B to be 206. So A plus 266 degrees should give us 360. Why are we saying so? From our last lesson, we said angles in a revolution. Angles in a revolution, a complete turn, make 360 degrees. So you realize that this side and the other side will make a complete turn. So we already know what 206. We don't know A. So A will be 152 degrees. A will be 152 degrees. So again, we have this diagram here, this figure. We are asked to find the value of A. We are asked to find the value of A. So again, these are parallel lines, parallel line, and then we have a transversal. You realize immediately that this angle and this angle are alternate angles. So alternate angles. So the value of A will be alternate, will be 30 degrees because they are alternate angles. So use algebraic skills to find the value of x in the following diagrams. So we have this figure here. Let us try to identify what figure this is. You realize it is a kite because we have two sides being equal. So we are told this is 95 degrees and this is 5x. You use the algebraic skills to find the value of x. So what do you notice? We said these two sides, these two angles of a kite are normally equal. Remember, in a kite, we only have these sides, only two angles being, two opposite angles being equal, but this angle and this angle are not equal. So we only have this. So we are saying this angle and this angle are equal. Then we can be able to say then 5x should give us 95. And the reason is opposite angles of a kite. So if we divide by 5, 5 goes into 9, 1, remain 4. So 45 divided by 5, we'll get 9. So x is 19 degrees. So again, let us use algebraic skills to find the value of x in this diagram. So you realize this is a quadrilateral, and we have said the angle sum of a quadrilateral is equal to 360 degrees. So that is the information that we can be able to use or to get or in this diagram. So every other time you're writing down a statement, you must give us the reason why. So we are saying 2x plus x plus 85 plus 95 degrees, that should give us 360. And the reason is because these are the angle sum of a quadrilateral. So we collect the like terms, 2x and x, that will give us 3x. 85, 95, if we add, that is 180. And that will be equal to 360. So 3x. If we take 180 degrees to the other side, in other words, subtract 360, 180 both sides. So let us eliminate 3 by dividing everywhere by 3. So the value of x is 60. We can be able to get the value of x, which is 60. So we have learned about triangles. We have learned about the angle properties of quadrilateral, the four-sided figure. We'll now move on to look at other polygons with different number of sides. So polygons, we are talking about a figure that has many sides, So we have looked at the triangle. So we have the different shapes. We have the triangle, and we have said the triangle has 3 sides, and the number of triangle in a triangle is 1, and the angle sum of interior angles is 180. For a quadrilateral, we have said we can draw it in terms of a triangle. If we draw a quadrilateral in terms of a triangle, then we'll have 2 triangles formed. The number of sides of a quadrilateral are 4, and the number of triangles are 2 for a quadrilateral. For us to be able to get the angle sum of the interior angles, we multiply 180 times the number of triangles that we get. And for a quadrilateral, you have realized that we have 2. So we say 2 times 180 degrees, that will give us 360 degrees. Then for a pentagon has 5 sides. A pentagon is a 5-sided figure. And then if we are able, so it has 5 sides. If we draw it in terms of triangles, you realize that we have 1, 2, 3. 3 triangles. 3 triangles. For us to be able to get the sum of the interior angles of a pentagon, we multiply the number of triangles times 180. So we have 3 triangles, each 180 degrees. So the angle sum of a pentagon is 540 degrees. An hexagon has 6 figures, or 6 sides. An hexagon has 6 sides. If we draw in terms of triangles, you realize that we'll have 1, 2, 3, 4. We have 4 triangles. And for us to be able to know or to get the angle sum of interior angles of an hexagon, we multiply 180 by the number of the triangles that have been formed. So the number of triangles are 4. So we multiply 4 times 180, and then we'll get 720. 720 degrees. We can continue and have an heptagon. Heptagon has 7 sides. 7 sides. If we look at the trend in the already polygons that we have looked at, you realize that when the number of sides are 3, the number of triangles are 1. If the number of sides are 4, the number of triangles are 2. The number of sides are 5, the number of triangles are 3. The number of sides are 6, the number of triangles are 4. So you realize that the number of triangles, if you compare, are less by 2, the number of sides. The number of sides. So if an heptagon has 7 sides, then what will be the number of triangles? So we less by 2, that will be 5. You realize also that the number of triangles are increasing steadily from 1, 2, 3, 4, 5. So if it is 5, then the sum of the interior angles are 900 degrees. What about for 8? If we have the number of sides being 8, what do we call a polygon that has 8 sides? We call octagon. An octagon has 8 sides. So because the number of triangles are increasing steadily, that means we'll have 6 triangles here. And the fourth angle sum of interior angles, we multiply by. So an octagon has 8 sides, and we have said the number of triangles are 6 because they are normally less by 2, the number of sides. Then what will be the angle sum? That will be 6 times 180 degrees, and that should give us 1080 degrees. So in summary, what are we saying? Given any octagon or any polygon, the number of sides being equal to n, then the number of triangles will be n minus 2, and the angle sum of interior angles will be n minus 2 times 180. N minus 2 times 180 degrees. So that will be the angle sum of interior angles of any polygon that has the number of sides n, and then the number of triangles will be got by subtracting n minus 2, and then we multiply the number of triangles times 180. That will give us the number of sides, or the sum of interior angles of any polygon. So again, polygons can either be convex or non-convex. So from our last lesson, we saw that convex polygon have all the vertices pointing outwards. So this is a convex polygon. We can also have non-convex polygon. The other name for non-convex polygon is also called concave. So this is an unconvex or concave polygon. You realize that we have vertices that are pointing inwards. So it means that one of the angles is a reflex. One of the angles or interior angle is reflex, more than 180 degrees, but less than 360 degrees. Let us now look at examples on polygons on how to calculate the interior or the sum of interior angles. So let us find the angle sum of a heptagon. So the first thing that you need to know is to be able to understand the name of the polygon with the number of sides. So before we continue, we can look at the different types of polygons with their different names. A three-sided polygon is called a triangle. A four-sided polygon is called quadrilateral. A polygon with 5 sides is called pentagon. One with 6 sides is called hexagon. 7-sided polygon is called heptagon. The one with 8 sides is called octagon. With 9, it is called nonagon. 10, we call it decagon. So a polygon with 11 sides is called a decagon, while the one with 12 is called dodecagon. So these are the names of the different types of polygons having different number of sides. So let's go back now to our question. Find the angle sum of a heptagon. So we have just mentioned that heptagon has 7 sides. We said to be able to calculate the angle sum of the interior angles of a polygon, we use the formula n minus 2 times 180 degrees, where n is the number of sides. So now that we know the number of sides to be 7, so we can now be able to substitute in our formula. So we have 7 minus 2, that will give us 5. Five times 180, that should give us 900 degrees. So the angle sum of an heptagon is equals to 900 degrees. Let's look at the next example. Find the angle sum of a decagon. You realize again that this one has 7 sides. Sorry, decagon has 10 sides. So we substitute in our formula n minus 2 times 180 degrees. Our n, which is the number of sides, is 10. So if we substitute in our formula, we'll have 10 minus 2 times 180 degrees. Eight times 180. So the angle sum of a decagon is 1440 degrees. So let's look at this other example, finding angles in a polygon. We have this diagram that is having a right angle, another angle is 80 degrees, another is 170, another is A, and the other is 95. So Pentagon has 5 sides. So the first thing that we need to know is to find the sum of the interior angles of a pentagon using the formula n minus 2 is equals to 180 degrees. So the sum of the interior angles of a pentagon is 540. So that means if we add all the 5 angles, that should give us 540. So we should be able to add 95 plus 90 plus 170 plus 80 plus A should give us 540 degrees, and that is the reason angle sum of a pentagon. So if we add all this, it will give us 435. So A, we subtract 435, A should be equal to 105 degrees. So for you to be able to calculate an angle in a polygon, you should be able to know the sum of the interior angles. And we have said, for you to be able to get the sum of interior angles, you use the formula n minus 2 times 180, where n is the number of sides. So if you're able to calculate, to replace n with the number of sides that you are given, then you can be able to get the sum of the interior angles. Then now you add the angles that we are given inside, then equate with the sum of the interior angles. Then you'll be able to find the value of the missing angle. So in our next lesson, we shall be able to look at, to go further and even look at or try to find the interior angles of regular polygons. But for now, that marks the end of our lesson. Thank you.